V2 minus V3.
V2 minus V3. Uh-huh.
Over 12.
12K ohm plus what?
6. So that would be V2 minus 0
Uh-huh.
over
V2
6.
over 6. Over 6K. Okay. All right, so that is equal to 0. So we have a couple of values here. We could plug in V1 and V3, correct?
Yeah.
So we could say V2 minus V1, right? Which is 12 over 12K plus V2 minus V3. That's going to become plus, right? Because minus, minus, right?
Yeah.
Over 12K plus V2 over 6K. Right. So what we're going to do now?
You could simplify this. Could do V2 over 12 minus 1.
So we'll do the LCM, can it? You mean? Can we do the
What was
LCM? The least common multiple first. Let's get rid of this
Oh,
division.
yeah, we could.
So we
So
could
it'd be
use 12.
6.
So that's equal to 0 equal. For what?
V2 minus 12
Mhm. Plus.
plus V2 plus 6.
Mhm. Plus
2V2.
2. Okay, so now we can add up everything. We only have one unknown, and that is V2, right? So what is V2?
So we could go
V2,
12.
it's a square come from.
That was supposed to be V2, yeah.
Yeah. All right, so this is supposed to be what now equal to?
12.
What about the V2s? Add up the V2s.
I guess we could add those up too.
What?
So it would be 1, 2. So it'd be 4V2
For V2. Mm-hmm.
minus 6.
Minus 6. Okay.
Over 12.
Well, you gotta put it over 12. You don't need to do it.
We could do equal 12.
Why? You don't need to do it over 12 because everything is divided through by 12 here already. So there's no need to do nothing else with the 12. You just drop it, right? Because both sides are the equal sign. Are you because 12 into 0 goes 0, right?
Mm.
So there's no need to include the 12K after that. You just say it's equal to 0. That makes sense? Because both sides are already divided by 12. And 12K into 0 goes 0 times. That's why. Right? That makes sense or no?
No,
Hmm?
no, that doesn't make sense.
Suppose you cross multiply by 0. What are you going to get? If you cross multiply the 12K by 0, what's going to be the answer? 0, right? But anything times 0 is 0, right? It's in the denominator. 12K is in the denominator. So if you cross multiply the 12K by 0, it's going to still be 0, right? So everything is going to be equal to 0 from here. So you just add these
Okay.
up, right? So you're going to have 4v2 minus 6 equals 0. So what is v2?
V2 would be 6/4.
Which is
Or negative, sorry. Yeah, no,
y negative.
6/4. Sorry, 6/4.
Which is what?
3/2.
No, no, no. So give me a better, give me it in decimal. What's that in proper decimal in decimal?
1.5.
1.5 volts. So that's what V2 is. So we have V1, V2, and V3. Now suppose you're to find out the currents, like I1. And if I1 is flowing where? There's a question. Suppose you want to find the currents. -6. But you have to find this current, for instance, this current. What's this current? Any idea? So this current, how could you find this? If this current is I1, how do you find I1? You know V2 now, right?
Mm-hmm.
Right, so what is I1? I1 is equal to what? Is it 12 minus, all right, here's 12 volts now, right?
Mm-hmm.
So 12 minus 6 volts, minus 6. Where's the 6 volts?
Why would it be? I thought V2 was 1.5. Why would it be -6?
What is V2?
1.5.
Okay, good. So where's minus 6 volts?
It's V3.
So V2 is what?
1.5.
Okay. So what would be I1? It's right here. It's right here. This one is I1. This one is I1. This one is I2. Make this label I2. So what would be I1 then? The voltage here and the voltage here. I1 is going to flow from here to here. Let's say it's flow from here to here. That's going to be what, 12? Is that 12 plus 6 now, right?
Why would it be +6?
This is
Thought it
minus
would
6.
be -6.
Right here is minus 6, right? So you got
Yeah.
to do the difference, right? 12 minus 6, right?
Oh, okay.
Divided by what?
9.
9K. which is 18 over 9K, which is what?
2.
So 2 milliamps will flow through here. What about I2 now? What about this one here?
So that would be 12 minus 1.5
Okay, that's going to be 12 minus 1.5 over what?
over 12.
Okay,
Okay.
okay. That's how much.
Yeah, so that would be negative
Okay, I'll be negative.
12 minus. Oh, what is the second one? 12 minus what? Oh, 1.5. I thought it was a 15.
1.5.
Let's see. That'd be 10.5
Hmm?
over 12.
Oh, that's what? Have a
That'd
calculator?
be 0.875
$7.5 what?
milliamp. Milliamp.
Mm. Okay, that's good. That's I2. What about I3? If I3 is here, what if I3 was there?
So it would be 1.5
I3 equal 1.5. Mm-hmm.
plus 6.
Plus 6.
Mm-hmm.
Plus 6. Mm-hmm.
Over 12.
Over 12K. My students keep dropping the K and coming up with the wrong answer in amps. Yeah, and then what is that?
0.625 milliamp.
0.625. Good. That's I3. What about I4? Where am I gonna put I4? So I1 plus I2. I1 plus I2. Here's I1. Mm-hmm. Whereas I1 is there, I2 is here. If I4 is this current, right? What is I4? Or maybe, what is it? What is I4?
There's no resistance there.
Well, you know
So
the
it would
current.
just be
Mm-hmm.
So it would just be the 12.
Current. What's the current? What's the I1, right? I1 plus what? This current, right? I2, right? These two currents add up together to give you the current here. Makes sense, right? This current plus this current give you this current, right?
Right.
That makes sense?
Makes sense.
So what is that? What is I1? I1 is what? I1
Two
is
2 milliamps.
2 milliamps plus I2 is 0
Point
point what?
875.
Hmm. So that's what?
2.875.
2.875. All right. That makes sense, right?
Makes sense.
And that's in milliamps. Hmm. Any more currents? What about the voltage now? Oh, I5 and I6. This one here, if you consider it to be I5 going through this 6K, what is I5? I5 is what? What's that? What's I5?
So that would be 1.5 is the volts there.
1.5 volts. What?
Over 6 kilo ohms.
Okay. So that is what?
So that would be 0.25 milliamps.
Okay. That's not 0.25, is it 0.5?
Yeah, 1.5 over 6, right?
Yeah. All right. So what is I6? If I6 is, here's I6 now. This is where I1 is here. There's I3. I3 is here, right? If I3 is here, we work out I3 already, and this one coming in is I1. That means I6 should be here, right? So what is I6?
There would be um -6.
We already know the two currents coming in. That means current entering must be equal to current leaving, right? Remember? So we have the sum of currents is equal to 0, remember, right? And that
Oh,
based
right,
on
right, right. So I'm sorry. So it'll be the current going in and the other current going in. So I forgot what which one is that one right
I3,
there? That's
I3.
I3
Yeah.
plus I2. I mean I1.
This one is the same current here and same thing here.
I1.
I1 was a 2 milliamps.
Yeah,
Mhm. And I3 is here.
0.625. So it'll be
Yeah.
2.0, 2.625 milliamps.
Yes, so I6 is equal to I1 plus I3. Is equal to what? 6.2
Two
point
point two
six
point six two five.
two five milliamps. Okay. Makes sense, right?
Yeah, makes sense.
All right. The question is now, that's it. There's everything, you find everything in this circuit, all the currents and voltages. Make sense?
Yeah, makes sense.
Right. Let's go to a clean sheet. No, no. What if you're supposed to work out something else? Let's say they gave you that, and we're gonna look into that one. Yeah, all right with that, or you want to try solve another one just like that? Are you okay with this one for now?
I think I'm okay with that one for now. Just gotta remember it.
Okay. All right, so we're gonna let's try a power one, right?
Mm-hmm.
Let's see what we can do with a power one. All right, let's upload one here. What? Device less than 41. Yes. Let's see. Check. Let's see this question for it. All right, how about this one? Let's see what you can think about this one.
So this one, a three-phase balance Y connected load is connected to a 120 volt line. The reference
Mhm.
voltage is VAB. The phase sequence is ABC, and the phase C voltage has a phase angle of 90 degrees. Most nearly, what is the magnitude of the line to neutral current for phase C? Okay, so we go to the three phase. Mm. Is the hmm. So we would have to do three-phase system. Line to neutral. So line to neutral. To all the magnitude. To neutral phase C. So 20. I know, let's see.
What's that magnitude at the line to neutral?
Um, so it would be the square root of 3.
Mm. So that's gonna be what? V. Where's it gonna be? VAB. So the line to neutral now is from like VA here to the neutral here, right? So how do you get to that from here if it's a balanced system?
Yeah, I'm not sure about this one. I'm not sure. Yeah.
So VAB and VAC, this is all balanced, right? VBC,
Mm-hmm.
all balanced 120 volts, right? They have a phase shift, right? So V and phase C, right? So what we got? V C to N. We're talking about from VC. Where's C? C is right here to N. You want to find the value of that. So it's going to be what? VCN is what? Is
Gonna
VCN
do
is here V. It could be
so
V
it's
what? Could be
one
VBC. It could be VBC. It could be VAB, right? Here VCA. But you gotta know it's whatever the case, it's gonna be what? VA,
Mhm.
VA what? You could say VCA. What's VCA? Divided by root 3, right? Should be that 120.
120 over square root of 3.
Yeah. So that's 120 over root 3. So that's like what?
Like 69.
69 point what?
28.
Okay. So once you get that now, realize they're asking for, yeah, the line to neutral current. But if you have the voltage, how do you find the current? If you have the voltage and the impedance. So that's gonna be ICN, right? Is it gonna be what? Voltage? What is the voltage? 69.28
9.28.
divided by what?
So it'd be
Impedance,
the impedance, yeah.
which is what?
Would it be 40 plus 30?
Yeah, that's 40 plus what?
30.
You sure it's plus? This is a capacitor, sir. What that mean? It's gonna be
One
minus,
as
right?
well. Oh, it's minus?
Minus J30. You remember, you realize that when you run all these capacitor and find their impedances, right? It's usually minus, and the inductors are usually plus, right? Remember that, right? So if you look at this right here, because of how the equation is set up, right? Remember? Because the
Mm.
property of the capacitor is more presents more of a correction for the impedances, which makes the value negative to balance out positive um impedance, positive reactances from the inductor, right? So now, what's the easiest way to fix this? Use a calculator. Can you find that in the calculator? Your calculator is good to do this. You see if
Mm,
the calculator can plug that in by itself and give us an answer in phasor form. Oh, you need to save your time and energy. So doing things like plug it in the calculator, make it easier, right?
mm-hmm.
Once you set it up, you plug it in the calculator.
Complex is 40. Where's the J? 40 minus 30. Mm-hmm. How do you convert it back? What is this? Oh, nope. I remember how to put it in, I just to add them, but I don't remember how to convert it back.
What happened when you put it in there?
I just, it just spits out 40 minus 30i.
Yeah, but
I
then you
don't,
gotta do on the calculator now you gotta convert it to divide it, the bracket around the 40 plus 40 minus 30 and convert it to the phasor form. There's a section to say phasor, right?
hmm,
You gotta practice that again, right?
hmm,
So the other thing you do is the complex conjugate, right?
mm-hmm.
You want to get rid of the complex out of the denominator.
Because then if I just plug it in, it's still converting it over to I. Forgot how to put it back in.
Mm.
Hold on. Because it would be why is it 3,464 over 3,125 plus 2,598 over 3,125i.
What coming out? This is
That's
good for math too, when you do the complex conjugate, right? So they're gonna give you a problem or two like this in math. In the math section, they might.
so I'm getting 3,464 over 3,125 when I convert it, which is like 1.10. So I don't see that answer there at all.
So this is at what angle? This is at 90 degrees, right?
Mm-hmm.
Right?
Oh, okay. Yeah, I didn't put in the 90 degrees.
Angle C volt is at 90 degrees. Came out better?
Oh, I gotta put it back into complex 69.28 at an angle of 90 degrees. So I'm getting for the top part 17.32 over 25i. We have to divide that by divided by 40 minus 30i.
Let's looking at
So now I'm getting negative 2598 over 3125 plus 3464 over 3125i. So what's that in? Let's see. Oops. mistake. So I'm getting negative 25,
Mm.
98 over 31, 25, which would be, oh, it's still off. I'm getting like negative 0.83.
Really? Why did it happen off? So this is like 50. If you just look by inspection, you'll see this. This is going to be 40 squared plus 30 squared. Arctan minus 30 over 40, right? You could do it like that. So this is going to be 30 squared plus 40 squared is 50 root. And then this angle is going to come out to be what? Minus 36.87. So what is the answer? The answer is what? 69.28 divided by 50. How much is that? That's like 1.39
1.3. Oh. Mhm.
amps. At what angle?
So you have to subtract out, divide the 90 degrees by negative 36.87.
Yes, you know what?
Mm.
Hold up. What's up? What's I got now? That's like what angle? You add them, right? When you subtract 90 minus 36, you're supposed to add the angles, right? You're gonna add up.
Mhm.
So it's gonna be 90 minus 36, right? So that would bring up to what, 126.87. No? Okay, you subtract the angles, but minus and minus give plus.
Oh. Oh, okay. So I think I was getting the same thing, but because it was like about negative 0.83, but that's with, but it looks like for this problem, you don't add the angles. It's just the 1.4 part of it.
Right, you just need the magnitude, right?
Yeah. So I think I was getting the same answer when I plugged it in. It's just that I was getting like negative 0.83, which when I just did it again, I got the same thing, but that's without
Mm.
that's with the angle.
So with the angle.
Yeah.
Okay. So this time they just wanted the magnitude.
Right.
They didn't need the angle. Okay, what makes sense?
Yeah. So what you did to get the uh 40, you did 40 squared plus 30 squared square rooted.
Right. When you have it like that in the, yeah, 40 minus 32, yeah. You can just square them and add them and then take the root to find the other one, to find the basically you're taking their sums, right?
Oh,
Sum of the
okay.
squares.
So that's where you were getting 50. And then the arctan of was where did you get that other angle from? The arctan of which one?
Yeah, the arctan of minus 30, the Q over R, the imaginary over the real, right? That's how it is. You gotta do arctan of Y over X, right? Based on that power triangle. It's based on that power triangle, right? If you want to find out the angle, then you gotta do that. You gotta do the arctan of Q over X, which is the imaginary portion over the real portion, right? That's in the formula book. That's in the handbook. We're gonna do more power problems, huh? I
I didn't
switched up
s-
to
I didn't
go
really
ahead.
see that
See
arctan
what?
of Q over X.
Mm. Yeah, man, this is P. Remember it's
P plus JQ.
yeah, so what was 40? 40 is what? Remember I said P, this is P, this is Q, and this is P. So P plus JQ, right? That's actually S. But if you want to find that angle, you're gonna always do the arctan of Q over. Okay, if you draw it up, right? Like that, or like that. The Q would be right here, and the J would and the P would be right here. So the arctan would be what? The opposite upon the adjacent. So theta would be here, right? So tan theta is equal to Q over P, right? Right here is S. Is it not S? S. Actually S. So these two S. So that's why we do that now is like we say, all right, to find that we do Q over P to find the angle. And to find S, you gotta square these and add it. Right? This triangle is there. You see that triangle, right? So this one here, this is Z. Actually, this one is actually Z, right? So Z is equal to what?
Z
What is Z?
equals A squared Z.
Is equal to R plus J what? JXC. Because that is Z we're dealing with. So, right? So it's the same thing. If you draw the triangle, it's the same thing you work out, all right? This is Z, which is R, and this is XC, which is on the imaginary line. Could be XL2. And then this is the angle theta. That's why they keep saying cos theta also is equal to opposite adjacent upon hypotenuse, which is R upon Z. So you can use that to find cos theta too, right? Hmm?
Mm-hmm.
Yeah, right. Okay, so hold on to that for now. It's just for to build up your speed. Let's go to another type, one more type problem. Then we can stop. Is there you understand what I'm saying here? No, you get this right?
Yeah, I get it. I just don't know if I'd get it on the website.
We're gonna do a lot more practice on Paul. We need to do more practice on Paul. What's the other sample problem we say we're gonna put up? Electronics.
Okay.
Yeah, the sample problem is an electronics problem. This is a transistor circuit. This source is a VCC equal 12 volts. Let's say VCC equal 12 volts. The DC, what we're doing is a DC equivalent circuit. Right? So this resistor is RC, right? There's a current flowing through here. There's a voltage VBE, quotient voltage across the base emitter. And then this voltage here is a VCE, quotient voltage. So VCE basically across here. Now, how do you find IC? What is IC? If RC is equal to 500, this is a 500 ohm resistor here. Right?
Mm.
So, what is IC? Where you find IC? And I'm telling you also there's a 3 volts here. VCEQ is 3 volts. Right? How do we find IC?
I see.
Yes, IC.
Uh, 1 beta IB. What would we use? What do we
We have the
use?
500 ohm, right? But you realize what's here to here? You could do like finding the current flow through here, can't you? Based on the fact that this is 12 volts and this is 3 volts across here. And then you have the 500 ohm resistor already, right? So you could say that's 12 volts minus 3 volts, right? Over 500. That makes sense?
Yeah, makes
12
sense.
volts is at the source minus the 3 volts right here between across here and ground and then divided by the 500 ohm, right?
Right.
So that works out to be what? 0 point what?
100. 0.018
0.018 amps. Is it amps, right?
ounce.
Yeah. No, what happened now? What happened to the base current? That's they say IB, right? Is equal to what? Beta? IC over
Beta, yeah,
IC over beta, right?
right.
That makes sense. IC over beta.
Yeah, that makes sense.
So what is IC? Is point 0.018 over beta. What's beta? Beta is given as 100. I didn't put it there. So beta is equal to 100. So what's that?
That's like 1.8 times 10 to the negative 4.
1.8 times 10 to the negative 4. Is there a way to call that out in terms of amps? Milliamps or microamps? So
Hold on. Go back to the definitions. That's negative 4. Negative 4 would be probably, what did I say? If it's micro, it'd be milli would be to the negative 3, unless we do, wait, 4. So we'd do 180
mm,
mic microamps.
it's perfect. So what happened here? Explain it to me. The circuit.
Mm. So with this one, you're trying to find, they gave us beta, and we need to find IB. So we still, in order to do that, we solve for IC. And from there we plug it into the we plug it into the equation and solve for IB instead of IC, since we have IC now. Is that good enough?
Again?
Was that good enough?
What was the last piece you said?
So we had the equation IC equals beta IB. So we solve for IB since we have IC.
Mm, exactly. Makes sense. Right. All right, so we're on the premise of hour here. I'm not gonna stretch you no more. Uh, so we need to what subject the last time we were on, we started electronics, did we? We didn't stop, right? Is that what we started? Our economics, we didn't finish. We were doing some econ. Was that what we left off the last time?
I think so. Hold on, let me just make sure. 'Cause I have that stuff. Hmm.
I think we were doing some
FA. Crap. When did we meet last time? It wasn't, was it October? Yeah, oh yeah, October. I think it was October 1st. Has it been that long? It's the 12th.
yeah, yeah. Give us a second.
Mm,
Right, it's fine. So
yeah, we
I
were
think,
doing those triode saturation.
yeah,
So
yeah,
we were doing
yeah.
MOSFETs.
Electronics. We're doing some electronics. So this is perfect, Bill. So maybe we need to get fed some more electronics. And right. So let's get some more electronics done. And then probably can do power after that, right? So do power and electronics together. I think it's good combination for you, right? You
Mhm.
do some electronics, read up and look at some problems in electronics and power, right?
Right.
But we run electronics, so I probably should send you a homework on electronics first. I'm gonna do that. So you're good though, right?
Yeah, I'm good.
Okay. Yeah, that's all it is. Don't let them pressure you too hard and put the work and
Well,
say, God,
who's pressuring me?
don't let them pressure you too much on the work.
Oh, yeah, we've been busy.
Hmm?
We've been busy, busy, busy. Yeah,
Busy day.
yeah, yeah. I think it's gonna slow down. It's been a little busy.
Don't slow down now.
Yeah,
Yeah, well, that's a good thing. Get the chance to study and do other
yeah.
things.
I know it's coming up. The exam is coming up. 12
What date you
in two
have?
months. 2 months.
So we're gonna have to push you hard
So
now.
just about 2 months. Let's see. Yeah, 2 months from yesterday.
Months from yesterday. Okay.
Mm-hmm. The
Okay.
11th. Oh, it's a Thursday.
We gotta push you harder
Oh,
now.
that's gonna be stinky. It's a Thursday.
Yeah, it's a Thursday. So
I'm
let's
gonna
push you
go.
harder this time, okay? We're ready to push you harder.
Yeah, I'm gonna have to take
2 months is
another
short. It's
day.
not a lot of time.
Mm-mm.
All right, so we're gonna go harder now. And maybe the last month we're gonna maybe do, 3 hours or something. A little bit more time. Last week, last 2 weeks at least. I gotta push you a little bit harder. So let me start feeding the problem, but when you get the problem fed, you gotta make sure you do it in entirety. Understand?
Oh yeah, instead of just doing a couple.
Yeah, yeah, it's not gonna work. You have to do it like in the exam.
Hmm.
So you get used to
Um,
that.
I think I ran out of time, so I think I definitely need to spend more time getting faster.
That's a part of the problem. All right, you need to step up moving faster and go all the way through to the problems. If you get 40 problem to solve, you have to sit down and solve them. You
But I've been
understand?
out of school for 20 years.
Well, you're gonna do the exam, so that you can't use that as an excuse. Because at the end of the day, you want to pass. So you gotta do what it takes, right?
Can't expect me to just be as
Yeah.
fast as I was when I was
Yeah,
a
but we're
junior.
trying to try. They have no pardon on you. They don't care whether you're in school 40 years or 10 years or 3 years. They want to make sure you pass. So,
No, I should have taken this a long time ago.
yeah, that's what I'm saying. So you can't create an excuse on that part. You just gotta step up and try to speed it up. We're
Mhm.
gonna have to try to speed it up. I'm gonna have to see how we can speed it up more for you so you can move faster. What's hindering you from going fast, you think?
Wish I knew.
Is it material? Is it material you think you can't come up with the answers fast enough or?
I don't know.
Yeah, we're gonna have to push you a little bit harder so that you increase the speed and find a way to strategize to get it to move faster no matter what. The speed and accuracy. But you gotta be able to do the problems fully first, right?
Right.
We're gonna work on that. When you're doing these, doing the problems, you gotta check your timing, eh? And then see where you're getting the bumps and bruises. What's necessarily stopping you from going fast as you should, and try to improve on that. You understand? That should be the aim.
Mm-hmm.
Anyway, I'm gonna let you go to your bed. That's what 1 hour for us, okay? So
Oh,
you
okay.
can send me the text, and then we meet Wednesday, right?
Yeah.
So Wednesday evening, 7 o'clock your time. That should be good. Okay.
Okay.
Is that good? 7 o'clock your time?
Yeah, I think that'll work.
All right then. All right, so let's convene on Wednesday, all right? So you have a good night and good to hear from you again.
Yeah, it's good to hear.
Yeah, all right. So sleep well.